Bitwise operators in Python are used to perform the operations on the binary representation of numbers. So when I say binary representation, we are going to deal the numbers having digits 0 and 1. Now bitwise AND is going to perform AND operation on two numbers in the binary format. Let's say we have taken x equal to 5, whose binary representation is 101, and 3, whose binary representation is 011. When I'm going to apply this bitwise AND on this binary number, so when the bits are 1 and 1, the resultant is 1. And when the bits are 0 and 1, the resultant is 0. And again 1, 0 gives me 0. So the binary representation of bitwise x and y having the values 5 and 3 is in the binary form 001, which in decimal number is nothing but 1. Now coming to this bitwise OR, which is nothing but called your binary OR operation on two numbers. Now how does this binary OR is going to work? So if we work on 1 or 1, so either of them is 1, then the resultant is 1. So because both of them are 1, so the resultant is 1 here. Now 0 or 1, because one of the bit is 1, hence the resultant is 1. Here again 1 or 0, the resultant is again 1. Now this 111 is in the decimal format, it is nothing but 7. Hence the result I am going to get as 7. Now bitwise exclusive OR is very similar to your OR, except the fact that when the two bits are same, suppose bit is 1, second bit is also 1, now the resultant is 0. Whereas in case of bitwise OR, if I take 1 or 1, the resultant is 1. So 1 exclusive OR 1 is 0 and 0 exclusive OR 0 is also 0, which means if either of the bits are 1, then the resultant is 1. For others, it will be 0. Now, if I'm taking x equal to 5, y equal to 3, so you can see 1 and 1 because both the bits are same, hence the resultant is 0. In this 0 or 1, I mean 0 exclusive or 1, the resultant is 1 because one of the bit is your 1. Very likely 1, 0, the resultant is again 1. Now this 110 in decimal format, it is nothing but your 6. So we have taken x equal to 5, y equals to 3. When I am applying x bitwise and y, the resultant is 1. And when I am going through x equal to 5, y equals to say 3. Now when I am going for x bitwise or y, the resultant is 7. When I am applying x exclusive or bitwise exclusive or y, so the resultant is 6. Now bitwise NOT, it is going to perform a binary NOT operation on a number. Let's say we have taken x equal to 5, which in 8-bit format, if I represent, I am going to get 5 zeros followed by 101. Now when I'm applying bitwise NOT on this x, I'm going to get like every bit which is 1 has been transformed into 0 and every 0 bit is transformed into 1. So as a result, all these zeros have been turned into 1, whereas this 1 has turned into 0, again 0 turned into 1 and 1 turned into 0. Now this binary number, as we see, the leftmost bit is 1, hence this number is treated as a negative number. So this last bit is usually utilized to decide whether the number is going to be a positive number or a negative number. So if it is 1, then it is a negative number. If it is 0, then this is going to be a positive number. Now because I found 1111 followed by 1010, so because the leftmost bit is 1, hence the result I am going to get is 6. Say we have taken x equal to 5 and I'm applying bitwise not on x, we are getting the result which is a minus 6. Left shift, bitwise left shift is the one which is going to shift the specified number of bits to the left, and as many bits have been shifted, those many zeros will be added to the right. Say, for example, we have taken 5, which is in 8-bit form is represented as 5 zeros followed by 101. When I'm writing x left shift 2, this 2 indicates that we are going to shift the leftmost 2 bits from this number. So when I take out these 2 zeros from the left, those many zeros I'll be adding to the right side. As a result, the resultant will be 0, 0, 0. You can see then 1, 0, 1, 1, 0, 1 followed by 2 zeros. Now this binary number, when I'm going to convert into an integer, I found the result is 20. It is a positive number. Why? Because the leftmost sign bit is 0 and 0 indicates it is a positive number. Very similarly, the right shift is going to shift a specific number of bits to the right, and as many bits are shifted, those many zeros will be added to the left. Now we take x equal to 20. So we have this is 20 in binary format. And when I'm writing x right shift 2, which means I'm shifting the rightmost bits, and these are now taken out, and those many zeros will be adding to the left. So as a result, what I get? I get 5 zeros followed by 101, and which actually represent the decimal number, that is your 5. Let's say x equals to 5. I'm applying x left shift 2. The resultant is 20. Now if I'm taking x equal to 20 and applying x right shift 2, I'm going to get 5.